Hello class, welcome to Chapter 12, Review for Geometry. This is going to be our last test for the year, so I hope you guys can finish the year out strong. Let's start by talking about our lateral, surface area, and volume formulas for each of our 3D figures for Chapter 12. So starting with prisms, those are our rectangular prisms, triangular prisms, our pentagonal, hexagonal, and so on, okay? It's a prism, remember, is anything that has two bases that are parallel. So like a triangular prism has two triangles and they're parallel from each other and they're connected by three rectangles. So remember, prisms have two bases that are parallel to each other. So starting over on the left, we have L equals capital P times little h. Remember, capital L stands for lateral area, which is the surface area of your 3D figure, except for the bases, okay? So the way you find that is you take the perimeter of the base, that's what the capital P represents in all of these formulas. Remember, capital P is perimeter of the base, times the height of the prism, okay? So if we have a triangular prism, you find the perimeter of your triangle, and then you multiply it by the height of the prism, and that will give you your lateral area. Your surface area is then taking that lateral area, so the capital P times h, and then adding on the area of your two bases. So surface area equals capital P times little h plus 2 times capital B. That capital B is going to represent the area of the base in all of these equations, okay? Capital B is area of the base. So since we're working with prisms, there's two bases, so we're going to multiply it by 2. And then the volume is the area of the base times height. A lot of you used to call it length times width times height when we deal with like rectangular prisms, cubes. But since we're going to be dealing with triangular, pentagonal, hexagonal, you want to just use the capital B so that way you know to find the area of the base and then multiply by the height, okay? One last thing about these prisms is when it comes to the triangular and pentagonal prisms, you want to remember to find the area of the regular polygon by using our area equals 1/2 times the apothem, remember, the apothem from chapter 11, times the perimeter of the polygon, okay? And you often do that by breaking your pentagon, your hexagon up into triangles, cutting them in half so that we have the right triangle, and solving using SOHCAHTOA, all right? All right, cylinders. Cylinders are kind of like prisms, except they are circular instead of made up with polygons. So the lateral area of a cylinder is found using 2 pi r, which remember 2 pi r represents the circumference of the circle. So if you think about it, it's really similar to a prism. Prism, you find the perimeter. Cylinder, you find the circumference. And then you multiply it by the height. Okay? And then for the surface area, you take that value from lateral area and you add 2 times the area of the base. Remember, the area of a base for a circle, or area of a circle, is pi r squared. And then for our volume, you do pi r squared, so the area of the circle times the height. All right, pyramids. The lateral area is 1/2. Don't forget that 1/2. 1/2 times the perimeter of the base, and then times a cursive L. That cursive L represents the slant height. So going down the side of the pyramid, let's see if I can draw one. Drawing's not my strong suit. We'll pretend that looks like a pyramid. But it goes down the side instead of straight down the middle, if you know what I mean. If not, I understand because my drawing's awful. But slant height, imagine you're sliding down the edge of one of the pyramids. Like you start at the top and you slide down the side. That is the slant height. All right? Surface area, you take the lateral area plus the area of the base. Since we're dealing with a pyramid, we are only going to have one base. Okay, typically it's a triangle or a square or rectangle. And then we have volume, which is 1/3 times the base, the area of the base, times the height. Okay, so the difference between pyramids, remember, you have that 1/2 for your surface area, and for volume, you have 1/3. Okay. Cone, if you're trying to find the lateral area of a cone, you're going to do pi times r times the slant height. Okay, so if you see a number written on the outside of your cone, they're referencing the slant height. If you see a number drawn inside your cone, they're talking about the actual height of the cone. Or if you see something that looks like this on the outside with the dotted lines, that is referencing the actual height of the cone. Then the surface area, you take that lateral area and you add the area of the base, the area of the circle that's on top here. Okay? So pi r squared. Then the volume, same thing for the pyramid. You do 1/3 times the area of the base times the height. Alright, and then a sphere. A sphere, you can only find surface area. You can't do lateral area because we don't have those sides. Surface area is represented by 4 times pi r squared. So you take the area of a circle and you multiply it by 4 in order to get the surface area. Remember, if you are given a great circle, a great circle is what is when you take a circle out of a sphere and the very center of that sphere is on that circle. That is considered a great circle. It's like the biggest possible circle you can get out of a sphere. Okay? Because the one that I just highlighted is much larger than, say, if I were to take a circle out of the top here. So hopefully you can see the difference. The one that goes directly through the middle and cuts a sphere in half, that is your great circle. Now the volume for a sphere is volume equals 4/3 times pi r cubed. Okay, it's really easy to accidentally type in a squared, so I know I'm giving you these formulas, but make sure you are typing them incorrectly and not just thinking, oh, 4/3 times pi r squared, because we're so used to saying pi r squared. Not the case, okay? Be careful. Take your time and double check your work. Alright, the last thing that we covered in this chapter was similar solids. So if I give you two, say, cubes, and I say, what is the ratio from cube A to cube B? So from A to B, you would do cube B, because that's my new one, over cube A, because that's my old one, and you take one of their side lengths. That is, so if we had cube A had a side length of 8 and cube B had a side length of 12, you would have 12 over 8, or you could simplify that, 4 goes into both, 3 halves. Then, if I wanted to know what the ratio of the volume, or not, well, I could do volume. I'm going to surface area first. If I wanted to know the ratio of the surface area, I would take that 3 halves and I would square it, and I would say the ratio is 9/4. Or if I wanted to do my volume, I still start back at that 3 halves. I don't take my 9/4. I start back at the 3 halves. You always want to start with the side length. And I would cube that. So I'd have 27/8. Now, let's suppose I start by saying the ratio between my surface areas is 9/4. What's the ratio of the volume? The way you would solve that, take the square root, because the square root undoes that square, and know, okay, the square root of 9 is 3, square root of 4 is 2. Okay, so that's my number from over here, so that's what I'm going to cube in order to find my volume. Alright, so you always have to go back to that first step, even if they don't give it to you, and you want volume. Or same thing, if you started with volume, you would take the cube root of 27/8 to find out, oh, it's 3/2, then I have to square it to get to my surface area. Okay, and that's all that I wrote down here. But hopefully this video was a nice little refresher for you. If you have any more questions, please be sure to reach out for some help. Have a fantastic day.